Okay, so you see, it's simple. We have this very simple idea of an atom. And we had said that we have this atomic number, which is the number of protons that are present in the nucleus. And this doesn't change. This is, the identity of the atom. It's what it is. And we had said that that atomic number determines how many electrons, how many negative electrons are there, and they're attracted. They have what we call an electronegative. They have an electrical attraction. They have an electrical attraction to those protons. Now, we had said that you have about the same number of protons and neutrons, and we had said that these are by far the greatest contributors to the weight or mass of the atom. And and we'd said those neutrons, they're just neutral. And so you might wonder, well, why do we even worry about them? But the difference, what can happen with those neutrons is that you can have different numbers of neutrons in the atoms themselves. And so we have a term that you've probably heard of called an isotope. Isotopes are atoms with different numbers of neutrons. Now, if we ponder, if we meditate on that word isotope, that's a weird thing to meditate about, but if we think about that word isotope, it probably conjures up even maybe some scary kinds of thoughts. Why is that? Radioactivity. Atoms that have a lot of extra, have heavy, what we would call a heavy isotope, they can be radioactive and they can be dangerous. That's why we talk about it. So isotopes are atoms with different numbers of neutrons, and the heavy isotopes, meaning the atoms with more neutrons, are often radioactive. If you were to look at uranium, we have multiple radioactive isotopes of them, uranium-238 and uranium-235. What that is, that's the weights of these heavy isotopes that are releasing scary amounts of energy and potentially doing damage, but also running our nuclear power plants. Okay, so we have this nucleus, and I think we've talked about everything that we need to about the nucleus, the atomic number, and the atomic mass, and isotopes. So I'll stop right there. See, this one's only 3 minutes.